Our topic is regression. When we do any sort of statistical analysis, we really should look at the data first. And when we're doing a regression, that's actually a fairly convenient thing to do. So I have two sets of, I have four sets of data here. And I'm going to take the first two columns. And when we're doing a regression, of course, we're looking at an independent versus a dependent variable. And here we would have y as the dependent variable and x as the independent variable. So I've highlighted the two sets of data with the x and y data labels. I go to insert, and I'm going to, if I'm looking at regression, a scatter chart is the good choice. And so I click on scatter chart, and I click on the upper left-hand corner one. And so you can see now that I have a scatter chart here in the spreadsheet. I go to quick layout, and if I click on the third one, layout number 3 at the top, it automatically puts a linear regression line in there. Now I can get there's a couple things I want to know here. One is I'd like to know the equation of the line, and the second is I'd like to know the r squared value. And so I right click on that line, and then I do format trend line, and it brings up this dialog box on the right, and you can see that I have several trend line options: linear, logarithmic. So if it's linear, this is a linear regression, and then I can go down here at the bottom and display the r squared value and the equation, and I drag them over here to the side so they're easier to see. And I see that I have an r squared value here of 0.06665. It looks like, to me, when I look at that, a linear model is the right one. Again, I can go in here to look at various things here. If I want to change to a different type of regression like exponential, I can click on the exponential button and fit. It automatically fits the best one through each one. Now, when I do that, I get in some sense, so I was at 0.66. Now with a power function, I'm at 0.7052. The only reason that you would not use the linear as opposed to one of these other ones is if you knew for sure that this should follow a power function of some sort. And if we don't know what the function is, we can't just go through and pick the highest r squared value and hope that that's the right thing to do, because we don't have any idea that that actually follows a power function. Now, I'll show you another data set here. So anyway, that's how you do regression. R squared values of 0.65 or so are pretty good. And I'm just going to erase this thing. We should use linear in the absence of knowing something better. Okay, so I'm going to I delete the function. I'm going to go to the second group here. So we'll just do two of them. And I'm going to do just the same thing. I click insert, and then a scatter chart, choose the first one, go to the quick layout, click on the number 3 or quick layout 3, and as I make this a little bit bigger, you say, well, it's pretty clear that the linear regression might not be the right one for this, because the points seem to have a curve. And so I click on the trend line, and we want to format that thing. So it's currently linear. And in this case, since we have a curve, I don't know which one that is. And so I would click on exponential. That doesn't really fit. Logarithmic, that doesn't really fit. We go to polynomial, and we can get a perfect fit on that. If we click on the equation and the r squared value, we get an r squared of 1. And so that is a perfect fit for those set of points. This, I don't have any trouble using a polynomial fit for that, because it is a perfect fit, and whatever the underlying function is likely to be that polynomial. If I choose a power function that doesn't fit, we have we have a decent R squared value, 0.7805. The problem here is, though, that in this case, when we have a perfect fit, that usually means that that was what generated the set of points. That was the underlying process. So when we're doing a regression, we're actually trying to find a model that fits the data the best. And if you have no idea what that model looks like, then choose linear. If you do have some idea whether it's a power function or exponential or something, then choose that. But I only choose those things that are, I only choose something that's not linear if I know for sure that it should be not linear. Otherwise than that, I just stick with linear. So that's regression as far as I'm going to explain it.